Let's get started. Evasive attacks presentation. So the thing that we should start with really is the expectation of what people think a security operations center looks like. Lots of people expect it to be a sort of dark room full of security professionals with banks of monitors up on the wall, displaying detailed views of the network, some kind of linked integrated system that flashes big red alarms every time that an intruder gets inside the network. And then, of course, a whole pool of security professionals ready with their green screens, Matrix style, ready to sort of jump into action and fight the attack. In reality, this really isn't the case. Yes, there are banks of monitors, but there are only banks of monitors because banks of monitors are required. It's not one integrated system that looks at your entire network. It's literally a dozen systems that are all looking at different aspects of your network. And the people that are staring at those monitors have to manually correlate the data from those different systems and those different screens to see whether or not there's something happening on the network. It's really security professionals doing this manual correlation that detect the breaches and detect the strange things that you need to pay attention to. Yes, security professionals are sat there ready with their green screens to jump into action, but it's very rare that you catch a security event as it's actually happening. These banks of systems are there for these security professionals to manually correlate the pieces of information from each of the systems to detect whether, when you add them all up, it equals a security anomaly. So what are the systems that are required? We've already said there's no one sort of SOC system. You don't say, right, I'm going to build a SOC, so I'm going to go buy some SOC software. You would go out and buy perhaps a log management or SIM system. A log management or SIM system is used to gather the log messages from all the different devices on the network. So all of your servers, applications, appliances, network devices, they all produce log messages for the things that they do day to day. 99% of the messages that are produced are sort of the daily dross, the things that you don't need to know from us or that are irrelevant from a security perspective. They're just letting you know that the machine is doing the job that it's supposed to be doing. However, that 1% that tells you that your firewall's being attacked or that a user account was created or that a piece of software that was installed, those have security implications. And that's the stuff that we really want to extract. So a log management or a SIEM or security information and event management system will gather the log messages from all of the different machines on the network, and then it will put them all into a single location, enable you to strip out the dross and just focus on the 1% of useful information. SIEM systems that have built-in correlation capabilities can then go a little bit further and start to detect security events, but only based on log data. There are other technologies out there, configuration auditing systems, for example. Configuration auditing systems allow you to automatically log on to machines every 15 minutes, take a snapshot of the device's configuration and then compare it with the snapshot that was collected 15 minutes ago. So this allows you to be notified when there is a change on the device, and it will tell you exactly what the change was. This would be, for example, something like Tripwire. Tripwire is the market leader in this space. Other technologies may include vulnerability scanning. These are technologies that can go and perform a scan of a machine, either from an external or an internal scanner. They'll detect the ports that are open, and the key here is also detect the services that are available on those ports, and then they'll attempt to make sort of minor security breaches, and if they're successful, it will report back. So for example, on a web server, rather than just telling you that port 80 is open, it will tell you port 80 is open, it's running Apache, the Apache version is 2.2, and that particular version of Apache is vulnerable to these list of vulnerabilities. So it gives you a really good idea of how attackers might be able to get in. It's particularly important on external facing devices, and gathering that information in is super useful for security professionals. There are other ones, we'll just whiz through them. Things like file integrity monitoring, checking whether key files in the organization have been accessed, things like configuration files, accounting databases, HR records, and so on. You've got asset auditing, particularly important and overlooked usually in security monitoring, but asset auditing would be tracking the user accounts that are installed, the computer accounts that are installed on your Active Directory and your your server's local databases, tracking the applications that are installed, their version numbers, whether they're up to date and patched or not, the services that are running on different servers. All of this would be regarded as digital assets, and tracking those assets and detecting changes to those assets is also very important. And finally, one that's really never regarded in when you look at security monitoring is performance. But performance monitoring is particularly important. I mean, the three steps of security are confidentiality, integrity, and availability. Availability is very much part of security. So being able to detect that a service is unavailable because it's been DOS attacked, because it ran out of disk space, because the number of database connections has been driven above its maximum, because it ran out of memory due to an application memory leak. All of these things are super important when it comes to security monitoring, and most people don't realize it. Security, if you implement all of these different systems in an effective SOC, then security pros need to be trained on all of them. So if you can imagine running a huge security operations center, something the size of, say, the BBC or the New York Stock Exchange, you've got all of these security professionals working in this center, and all of them have to be trained on the different technologies, definitely to use them, but some of them will have to be trained on administering all of those different systems. The administrators will need to learn how to install, update, and take care of them. All of those servers need to be fed and watered and backed up. And then, of course, there are gaps between them, and that's some of the things that we're going to be looking at today. So, a use case. Let's take a typical use case example of what happens in the day-to-day life of a security analyst working in a SOC. Somebody makes a change on your gateway firewall. There is a log message to say that a change has been made. This is the point of security information and event management. You may have received 10,000 logs from that machine that day, and the one log message that says there's been a configuration change is super important. That log message will say, this user made a configuration change from this machine at this time. It's very, very important information. But if you want to know what the change was, you're not going to find that data in your SIM. So having an expensive SIM is great. It tells you when a change happened, it tells you who did the change, but it doesn't tell you what the change was. If you want to know that, that's not in your SIM. It's something that you'll find using manual correlation inside your configuration auditing system. So you log out of your SIM and you log into your system that took the configuration snapshots, and then that will tell you exactly what the change was. And so by some manual correlation, you now know what changed, who did it, from where, and when the change happened. But wait, did that change introduce any new vulnerabilities to my network? Did it introduce any performance issues to my network? Were any users affected by the change? How did it impact our compliance? Did it put me in or out of compliance with PCI and ISO and all of those compliance policies? Those are not the same system. Those are yet more systems. So in the first part of the investigation, we've logged into we used our SIM to tell us that the event happened. We then used our configuration auditing system to tell us what the change was. We've then used a myriad of other systems, vulnerability analytics, performance and availability monitoring systems, flow monitoring systems, asset monitoring systems. We've used those to go and tell us what the effect of the event was. And so the day-to-day lives of a security professional is really one of understanding the systems that are in place on the network and understanding how to extract information from those systems in order to determine whether or not there has been a security incident. The use cases that we're actually going to look at today are ones that can bypass that process. So given that that is the process, what attacks are out there that can bypass it? The first use case that we're going to look at is Dark Reaper. Dark Reaper was an attack that was particularly prevalent in 2015. It was used to take down 39 of the 50 US.gov websites via a hacktivism group called Vikingdom 2015. We'll go through and look at some of the places that it's been used, but it was a particularly dangerous attack and had a pretty big effect in the year of 2015. So, just in case we're unsure, we'll go through some very basics on what is DDoS. DDoS, well, a denial of service attack is making a legitimate service unavailable to legitimate users with illegitimate traffic. So you effectively bombard a server with illegitimate traffic so that it can no longer respond to legitimate users. A distributed denial of service, or DDoS, is when multiple attackers attacking the same target. When DDoS first came out, it was first used as an attack, they used what we call a layer 4 distributed denial of service attack. This is where you bombard a server with SYN packets, just normal TCP packets. You attempt to start a conversation, the server responds to say that it's ready to have that conversation, and then you never respond to it. And you just bombard the server with these packets and keep forcing it to wait and wait and wait until you've hit it with so many of those packets that it can't respond to normal traffic. You can do this via sheer force. So if you've got a server that has a 2 meg internet connection and you send 10 meg of traffic to it, then it can no longer respond to any legitimate requests because the legitimate requests can't get through. If you've got, or you can do it sort of more intelligent, like mentioned with the SYN flood attack. And the SYN flood attack is where you're actually tricking the machine into running a process in the background, and running that process in the background stops it from responding. This was the tool of choice for people like Anonymous. So when they got into trouble for taking down Visa and MasterCard and PayPal, it was because they got tens of thousands of kids around the world to download an application called Low Orbit Ion Cannon. And Low Orbit Ion Cannon was sending these very basic layer 4 DDoS or denial of service attacks, but because they had 10,000 kids sending it over their 2 meg internet connections, it suddenly added up to this huge volume of traffic. I have to say that in this day and age, layer 4 distributed denial of service attacks are less relevant. They don't last very long. ISPs, particularly in countries like the UK and the US, can now strip these attacks out at the network layer. They can detect pretty quickly that the attack is taking place. They can automatically divert the traffic that contains the attack through a cleaning center, and then that cleaning center strips the traffic out. So these have become less relevant. Even Anonymous don't use them for so much these days. And even when an attack like this does happen, it doesn't happen for very long. There are also services out there, such as CDN services, or content delivery network services, people like Cloudflare and Akamai, where they can basically proxy all of your internet connections through their huge data centers, and they can strip all of that nasty traffic out. However, there was a chap called The Jester. If anybody's not aware who The Jester is, go take a look. He was named by Time magazine as one of the 30 most influential people in internet history. Yet that's the same list of people that contained, the inventor of Google, the inventor of Hotmail, the inventor of Yahoo. This guy was on that list, and he was a hacker. He's effectively a right-wing hacker, so he's often at loggerheads with Anonymous. In fact, when they took down Visa, MasterCard, and PayPal because they refused to take donations for WikiLeaks, he took down WikiLeaks by himself from a laptop. He showed that he was in control of the attack on an IRC channel by telling people, refresh the page now, and the site came back up, and then said refresh the page now, and the site went down again. So he showed that he was in control of the attack by himself, which was pretty impressive. He then went on to go and do lots of other things. When Anonymous were trying to attack Westboro Baptist Church without much success, he was able to take it down, and reported that he could do that from a mobile phone. The guy was incredibly impressive and has continued to be active even to this day, although his identity is still unknown. He used a special kind of attack, a layer 7 distributed denial of service attack that was actually attacking vulnerabilities in specific applications. So rather than attacking the server and trying to make the entire server unavailable, he was attacking the application that was responding to the request. So if you made a web request and the server was running Apache, he would attack the Apache application using vulnerabilities in the Apache application and make it unavailable. So even though the server was up, it wasn't responding to web requests. So in effect, he took it down, but without people noticing. That was extremely powerful. And because the attack was attacking the application, it didn't need 10,000 kids to all be running a program. He could do it himself from a laptop. There are some arguments that his attacks were limited to bugs in certain applications. So, you know, he would find a vulnerability in Apache and then attack that. He would find a vulnerability in different web servers and attack that, rather than having one attack that could attack everything. But he was so clever that he created sort of lots of different applications to attack lots of different service provision software. Okay, so now we've gone through a bit of a history on what distributed denial or what DDoS is and the different types of DDoS between layer 4 and layer 7. Let's take a look at very quickly what the Tor network is, or the darknet. So Tor stands for the onion router. It's a method of sending traffic across the internet in an anonymous way. Effectively, this guy can send traffic to this guy, and because it goes through 3 hops and via a system of layered routing and encryption, each step along the way only knows the place that it received the traffic from and the place that it's sending it to. So this first node in the system only knows about where the traffic came from and where it's going to. This guy only knows where it came from and where it's going to, and this guy only knows where it came from and where it's going to. So no node along the entire process is aware of the original source of the traffic and the actual destination of the traffic. This allows anonymity. This was created by the US Naval Research Laboratory. It was designed as an anonymous communication network for US intelligence services. It was created with good intentions. When it became a publicly available network, or they released the source code for it, it was used with noble intentions. It was designed to give a voice to people in dissident countries. You know, it is used today in places like Syria and China, from behind the Great Wall of China, so that you can get messages out. It was used in all of the Arab Springs from Libya and Egypt and Syria. So it was used with good intentions, or it was created with good intentions. However, it is misused by many. It is full of vile content. It is the new home of child pornography and animal pornography, which I didn't even know was a thing until we started researching this. The site hosts are anonymous. Therefore, you can post a site on the Tor network and nobody will be able to tell where that server was actually hosted, and therefore you can put a server on the Tor network without anybody knowing who you are. And that gave rise to lots of things like the Silk Road, where you could go and buy and sell drugs and passports and assassinations and, you know, ammunition and all sorts of terrible, terrible things. So given that the hosts are anonymous and that they are immune to distributed denial of service attacks, it's a pretty attractive place to host terrible, terrible content. The reason why they're immune to traditional distributed denial of service attacks is because the Tor network is so slow, because it has all of these kind of layers of encryption and routing. Each step of the process takes too long. You can't send 10 meg worth of traffic. You can't send 10 gig worth of traffic over the Tor network. You'd end up burning the whole network down before you took out the server. So traditionally, it's not been possible to attack sites on the Tor network. And even where you've got right-wing hacktivist groups, they weren't able to take things on the Tor network down until there came a guy called Tor Reaper. As the name suggests, his entire purpose seemed to be taking down sites that were on the Tor network. He attacked child pornography and animal pornography sites originally, and then went on to attack ISIS and terrorist-related sites as part of a group called GhostSec. He needed to attack sites on the Tor network, specifically for child pornography and animal pornography, because there's so many of those sites there. He wasn't able to use traditional layer 4 distributed denial of service attacks. And so what he did was created an attack called Dark Reaper. Dark Reaper we knew was a layer 7 attack, but it was a layer 7 attack that was capable of attacking over the Tor network. This was very key. It was a new thing that we'd not seen. That's what piqued our interest in the initial stages. We also found that it didn't seem to be application specific. When we were running checks on systems that he'd taken down, when they came back up again, we would take a look and see what those systems were running. And they would be running, some would be running Apache, some would be running Nix, some would be running older versions, some would be running newer versions. It didn't really seem to matter. So it was quite interesting that he created an attack that worked through, that worked across the board on all the different attack types, on all the different application types. It also seemed to work through content delivery networks, which was very interesting. So we at Pervade, we reverse engineered his attack. We replicated his source code. We were able to send an attack across the Tor network, and we were able to have that attack bring down a web server. The really interesting thing is the exploit that we believe, or the vulnerability that we believe he's exploiting is actually a vulnerability with the HTTP protocol rather than any individual application. This is pretty significant. It means that it will work across all web servers. It also means that you can't really write rules to block the traffic because it just seems like legitimate traffic. We'll go into that into more detail in just a second. It also doesn't need to be run on a mass scale. We were able to bring down a corporate web server using a Raspberry Pi. Also, because it's using a Tor client and Tor clients can allow people to change their source IP address, it means that the source IP address could change every second and the attack would still continue. The most interesting thing that we found about this attack, though, is that in the entire time we ran the attack, and the idea was to get above 256 processes, because the default number of processes available in an Apache server is 256. If you can launch 257 processes, you will make the web server unavailable. The way that it's doing that is by writing a request to the web server. The web server then says, okay, I'm listening for the rest of the request, and it never updates it. This used to be called a slow post attack, and it was fixed. The exploit was fixed, but this one seems to work. It's a variant of the slow post attack that still works even today. We got to a point in this web server where we attacked it. We were checking how many HTTPD processes were running. We got to 257, and we confirmed that the web server was no longer available. In the entire time that we were running this process, there was not a single error log written, and there was not a single access log written. This was incredibly significant. This meant that we took down a corporate web server, and in the whole time that we brought down the whole web server, we didn't create a single log. So in a security environment that is using SIM as their indicator as to whether or not there's an attack, they would never have even noticed that this happened. Literally, the entire corporate web server would be brought down, and the whole website and any web services would be offline, and the security team would be sitting there without realizing anything bad had happened. But we say, that's okay, right? Because these guys they're not using it to attack corporate web servers. They're using it to bring down ISIS and things like that. Well, it's not really always the case, even though it's usually the case that they're attacking these kind of ISIS sites. And these are real screenshots that were posted to Twitter by Tor Reaper and other members of the same hacking group, crew, whatever you call it. But one day they posted a message that said, it seems UK2, if you're not aware, UK2 is one of the largest hosting providers in the UK. They host tens of thousands of sites. Seems that UK2 are not the great host that we once thought. ISIS site has not been removed and they're ignoring us. Guess we'll have to remove it. And then the Tor Reaper posted a picture of him taking down the ISIS site that he was complaining about. But somebody else posted a message saying that UK2 was down, and we were monitoring this in real time as it was happening, and we confirmed that this was down ourselves. We also got in touch with UK2 to let them know. And basically, yeah, their whole website, corporate website, went down. Hours later, there was a tweet that said, we're trying to get an update from UK2, because of course they don't have a phone number. All of their support is done through their website. So if their website's down, they can't get updates and they can't communicate with UK2. So we're trying to get an update from UK2. regarding the ISIS site. Stop attacking it if you are, please. They're trying to help us. So this is the Tor Reaper guy kind of suggesting that it's not him that did the attack. Whether or not that's true, who knows? You know, you can't really trust these guys, I guess. But the whole point here is that this is an example of a corporate business whose entire purpose in life is keeping websites online, was not able to keep their own website online or their customer against this attack. And this is people that got caught in the crossfire. So even though these hacktivists seem to, you know, be doing this with good intentions, innocent people do get hurt, and this is the problem. But what happens when the attack gets in the hands of some really nasty people? This is a group called Vikingdom 2015. It says we may get 3 layer 7 servers that knock over protective sites. They've then posted some ridiculous number showing that they probably don't understand how the attack works. But these guys are saying that they've got layer 7 attacks. They've gained access to layer 7 attack servers. They later posted a message to the US government on SoundCloud saying, because of the atrocities that you're committing against black people in Ferguson, we're going to take down all of your .gov websites, which they then proceeded to do. They took down 39 of the 50 .gov websites, including main.gov. They took that down for 90 days or something. It was insane. They took nyc.gov offline. They took Connecticut.gov offline. They took all these sites offline, and it's just a group of kids. We also saw lots of screenshots on Twitter from various people showing how that they could take down sites even through Cloudflare. Cloudflare is the biggest content delivery network. A content delivery network is basically a service that strips denial of service attacks out. So very, very powerful attack, and more importantly, one that doesn't generate any log messages. There are other types of attacks, conscious of time, so I don't want to go into this one too deeply, but there are other types of attacks that don't leave any log messages behind. A particularly new one that lots of people are exploring at the moment is the use of WMI. WMI stands for Windows Management Instruments. It's been available on all machines since NT4. I mean, you had to install it on NT4, but since XP in 2003, it's been installed by default and available by default. It uses connection protocols such as DCOM or WinRM to connect to or allows connections via WinRM or DCOM, and allows people to remotely run queries. There's lots of tools available for accessing WMI. There's even tools available for non-Windows machines. And there's even a language called WQL. It's kind of like SQL, but a little bit different. And it essentially allows people access to properties and methods on Windows machines, so that you can either request information like CPU usage, disk space, you can get log messages via WMI, you can get all the different information about a Windows machine from WMI. It also allows people to execute methods like launch processes, restart services, and so on and so forth. We as a company, actually, Pervade Software, we use WMI extensively to go get information from Windows machines that we use for monitoring. So it is profoundly useful. There's lots of uses for it. There's hundreds of millions of dollars of industry that are based on the fact that WMI exists. However, it wasn't until 2010 that we sort of started to see people using it for attacks. Not many people realize this, but WMI was actually used in the Stuxnet attack in 2010, even though the worm was introduced via, suspected to have been introduced via a USB. The virus was actually using WMI to store information in order to execute the code later on. That was really the first instance of where we'd seen WMI being used in a attack scenario. It has progressed since then significantly, though. In 2014, there was a script that was written and uploaded to GitHub. It's still there today if you want to go play with it and test it, by a guy called Andrei Dumitrievich, I think. I'm very bad at pronouncing the name, so I'm very sorry about that. What this actually does is interesting. Rather than querying or trying to manipulate one of the existing WMI namespaces, it allows a user to create a WMI namespace. This is actually even worse because it means that it would then be hidden from view. It would be hidden from the administrators that are looking after the system. The namespace can be used to store the payload of an attack, and it can be then used to store the results of any data gathering, and it can be then queried remotely to gather the stolen data. So here's the interesting thing. WMI is supposed to be enable remote software to access information that's stored in a table, this WMI table. What the new functionality allows you to do is create spaces in that table and store whatever you want in it. So as long as you've got one machine and one valid user credentials once, somebody can create a namespace in this WMI table, and in that table they can store the actual VB script code that they want to execute, and that VB script code can do anything that it wants because the WMI system runs, because the WMI feature runs as the system account. So you can store in that WMI namespace lines of code that will go off and, I don't know, create a user account with administrator privileges. It will go and install some software. It will go and download some malware, whatever it happens to be. That code can actually be stored in WMI, and it will be run as WMI, which means it will be run as the system account. That data can then also be queried remotely to extract any information. So if you've got a piece of software that's sitting there trying to mine credit card information, if you've got something that's trying to mine encryption key information, it will then store the data in its own WMI namespace, which, because the administrators don't know it's there, is pretty much invisible. And then it can be used, it can be queried to extract the information after the fact. This is known as APT29, as defined by Mandiant FireEye. Those guys did the primary research on this. We pretty much just picked up their research and played with it to see whether or not it was true and whether or not it could happen in a real environment, and we found that it absolutely can. And attack autonomy. You've got something effectively called event consumers as well within WMI. This is pretty cool. In addition to being able to create your own namespace, like the previous software that we discussed, what you can also do is create on-event triggers. So on-event triggers are creating something that happens on an event. So you can say, every time the system reboots, execute this code. And so every time the system reboots, it can be used to, for example, create a user account with administrator privileges that will give you access to anything going forward. It can reinstall a rootkit. This could be potentially hugely dangerous if you've got, for example, you run an antivirus scan to clean the system of any rootkits, and then every time the system reboots, it reinstalls the same rootkit. So it could actually be used to be very annoying and to give attackers persistence on systems. Attackers do require credentials initially. This is very key. In order to set this WMI namespace up, and in order to create these event consumers to do on-event actions, you would need a valid set of credentials once. You would need to be logged in, as a valid user once, or trick a valid user into running a script. However, the biggest key is that actions that are performed by these event consumers, by these on-event triggers, are not logged to the event log. They're only logged into a forensic file, which is located here in the location you can see on the screen. This file is an absolute nightmare to read. It's not something that you can suck into a traditional SIM or anything. You've got a sample of the file here. It uses these kind of hex locations and all sorts of terribly formatted data to store what WMI has done. It's not logged to the event log. What this means is anything that these WMI on trigger events are doing is not logged, and it's being run as the system account. This is a disaster. There's something that's being run as the system account, and it's not producing any log information. This is very, very, very bad from a security perspective, and it's absolutely possible right now. We tested this last week. It runs fine. So again, with the use of a custom namespace, even object.data logs can be avoided, because if you have a custom namespace, then it's doesn't log to the main object.data file. So those are a few of the attacks that can be run, and both of those sets of attacks that we've looked at the in-depth anatomy of, neither of them would produce log messages. So the first one, the Dark Reaper DDoS attack, that entire attack would run and have its devastating effect without a single log being produced. And the WMI attacks, all bar the initial logon that would be required in order to run the to run the script to set up this WMI stuff, which would just, in most cases, just be seen as a legitimate access via an existing administrator account. All bar that initial access, everything that it subsequently does not generate any log information. And so both of those attacks would be completely missed by traditional security monitoring architecture, this traditional security monitoring approach. Detecting these attacks. Detecting Dark Reaper is actually really easy. It can be done with free software. Most free performance monitoring systems will allow you to detect the number of concurrent connections on your Apache system, or the number of concurrent processes, Apache processes running on a web server. And I'm using Apache as the example, but you could drop in any web server as the example there. And it would be able to detect that, the box is about to crash. So if the security team had access to performance monitoring systems, they would perhaps be able to detect that the box was about to fall over. You are able to then correlate the fact that the box is about to fall over with the firewall logs to see where the traffic was coming from. If you wanted to identify the source of the attack, you wouldn't be able to just use the firewall logs, because of course these logs would just look like normal web traffic, unless you had the performance data to know that they were having a negative impact on the box. Tor routed attacks would still be anonymous though. So if the attack was being routed through the Tor network, as in the case of the Tor Reaper, you still wouldn't be able to identify the source of the attack. But if you had the performance monitoring system in place, you'd be able to detect the fact that the attack was taking place. With the WMI event consumers, you can get specialist tools. There's one called Flare WMI, which is produced by FireEye. This is for parsing the objects.data file, and that can then be used to suck those events into a security analysis tool. It's still not a perfect situation, because the objects.data file is not sort of a continuous record. It's not a log event file. It's basically a file that contains everything that's ever happened in that WMI namespace. And so if you catch the attacks happening, they'll be appended to the bottom of this huge file that you would need to pass out every couple of minutes in order to see whether something was happening. Also, if the payload was stored in WMI, or if it was in fact in a different namespace, then it wouldn't be logged even to the object.data file. There is actually a really interesting workaround to detecting these. You can use an event consumer, which is the same thing that the attackers would have created. So the attackers create an on-event consumer, which effectively performs something every time the machine restarts. You could actually set up right now in your environment on-event consumers that will look for the creation of on-event consumers. So you can actually use the same method as the attacker to detect what the attacker's done. So it's kind of a nice circular serendipity there. And it's not just these examples. This is what I would like to stress. There are lots and lots of these examples. We have more, but we've run out of time in this presentation to go through them. There are lots of attacks out there that do not generate logs and that would be missed by the traditional security architecture. Happy to show people other attacks. If you want more detail, just ask me afterwards. But the whole point of running this presentation is to say, look, we need a radically different approach. We can't continue to use this model of, right, well, let's use our SIM to see if we can detect something, and then let's go and use these other technologies to go and investigate it. Or even if you switch this around and you say, right, well, let's use our config auditing system to go detect something and use our SIM to investigate, which is actually a much better way of doing it. But even in that example, there would still be attacks that could slip through the grid with a lack of visibility. What we need is the thing that I said was missing in the very start of this presentation, that said, don't have multiple systems. Don't have swivel chair management. Don't require a dozen monitors on the wall of your SOC so that you can run a dozen systems. Have one system. Have one system that is able to track all data types, that's able to universally pass all data from all different systems: log, config, performance, asset, flow, file integrity, the data types that we haven't even thought of yet. Let's get one system so that we can get all this data into one place and have complete visibility. If there's a performance issue, it shows up on the same system that the SOC guys are looking at. If there is a security issue, it shows up on this, that's detected in the logs. Have it in the same system that shows the configuration changes, the new vulnerabilities that have been added, your compliance with PCI DSS, and then automate that detection based on behavior and based on thresholds, so that you can say, well, my CPU doesn't seem high, it's only at 50%. But if the CPU is normally 10%, that's a security behavior problem. So having all the data in one system allows us to future-proof our security monitoring. It allows us to detect attacks that currently slip through the net, and it allows us to protect against zero-day attacks that haven't even been discovered yet, which is all the things that I just said, but are now coming up on the screen. It also has the operational benefit of being one system for staff to be trained on, one system to maintain, upgrade, patch, feed and water. It's also one system to back up. It allows security professionals to continue or to spend more time doing what security professionals should be doing, which is detecting attacks, not administering systems. And finally, this approach does not replace security professionals. It just allows them to spend more time doing security stuff. It allows them to spend less time doing admin work and swivel chair management and manual correlation of data. Finally, just a few thanks to people that actually contributed to the content of this presentation. Dan Lewis, the head researcher here at Pervade. There's also Matthew Graber at Mandiant FireEye for the great work on the WMI content. Ty Miller, also on the WMI content from Threat Intelligence, and of course the Jester, who provided me with lots of information about his attacks on private chats. If anybody doesn't know who the Jester is, please feel free to go research him. You can reach out to him on Twitter. He's very responsive. He's a real nice guy, and even though you'll never know his true identity, he is somebody that you can openly chat with. Very, very clever guy, and there to help security professionals. And that's the end of the presentation. Okay, so in the second presentation, we're going to take a look at Pervade software. Pervade software, our system, is the combination of SOC, NOC, and GRC. That's Security Operations Center, Network Operations Center, Governance, Risk, and Compliance. We put all of these things into